So music is an inseparable part of our lives. In the 2000s, music streaming platforms such as Pandora relied on manual curation. Though better than discovering songs by pure luck, discovery aided by manual curation does not allow individualized recommendations. Therefore, Spotify, a commonly used music streaming platform's success in this digital age is undeniable. As you know, it is able to generate top 50 hits, and therefore songs that appear on its top 50 hits have profound influence on our culture. So here is a question that motivates our project. What does it take to make a song popular? Is there a method to this madness that is being a chart topper? Great songs are released year after year, but only a few ends up in the list. And if popularity of a song might be predefined, is it going to affect the music industry in the future? Can computers generate popular songs instead of human hands and replace some of our people? Before building our model, we conduct a pre-analysis. Our first step involves pre-processing the data of our 169,000 songs with 19 features such as its acousticness, name, artist, genre, and tempo. In order to have a deeper understanding of how feature contributes to the popularity, we made several graphs to illustrate. As you can see, the first graph shows a linear positive relationship between years and the song's popularity. It's very obvious that this more contemporary a song is, the higher popularity it can achieve. Such correlation is related to Spotify's rather late launch in 2008 and a possibility of different calculation of popularity for old data songs. We thus decided to subset the original data set into songs from 1980 to 2020 to reduce the variance of the data.
So this graph visualizes pairwise relationships in this dataset. Now, we can closely observe each feature's relationship to popularity, which is not really intuitive as the graph contains too much data points. So we use the correlation heat map instead to show the features like loudness, danceability, and explicit have stronger correlations to popularity. And here is the features we decide to use after feature selection. And after we look into the Pearson correlation matrix. And below that is another correlation matrix between our selected features to just to spot correlation between independent variables, which might cause multicollinearity. As a result, we reduced our final choice to 5 features: danceability, instrumentalness, ear, explicitness.
In addition, we make graphs on features we've dropped to understand reasons that affect the high and low of correlations. This graph shows the energy versus popularity. And you can see there is no distinct correlation between two variables as more modern songs with zero energy still achieves a higher popularity. On this graph, we set up a figure with joint and marginal values on the bivariate data, tempo, and popularity. As you can see, songs have very centralized amount of tempo, which does not necessarily have a direct relationship with popularity. So now we enter the process in building our model, and we use a regular linear regression model and another linear regression model with stochastic gradient descent because our prediction is for a numerical result. Thus, we decide to use linear regression model. But since our data is of large amount, it would be more efficient if we use the stochastic gradient descent. The train accuracy we achieved from stochastic gradient descent, as you can see, is 91.124. And our test accuracy is 89.129. The regular linear regression train accuracy is 90.2425. And our linear regression test accuracy is 89.399. As you can see, after our pre-process on data, our model has achieved a rather good result. But for our further exploration on this project, we decide to apply PCA as well as cross-validation to further improve our model. And then we will keep you guys updated. Thank you very much for listening to our presentation.